Today's learning topic is limits of rational functions. X approaches C, a fixed number, or x goes to infinity. Our discussion will be based on three aspects: limits in determinate form, indeterminate form, and limits at infinity. For the determinate form, the limit can be any arbitrary number or special number 0 or infinity. This is a special case if the finite number is 0. Here, finite number does not need to be a small number. It can be a very large number. As long as it is fixed, it's a certain number. Indeterminate form. Here we only focus on the limits of rational functions. So we choose 0 over 0, infinity over infinity. For these two indeterminate forms, the key fact is the speed of approaching 0 or approaching infinity. For 0 over 0, we compare the speed of numerator approaching 0 and the denominator approaching 0. Let's randomly choose two very small numbers. When the amount of zeros in top and bottom are pretty close, like here 100, 100 zeros, 99, 98. So this fraction approaches 440 or 400, etc. If the numerator approaching 0 is much faster than the denominator, then the limit is 0. We flip this fraction, this goes to infinity. Similarly, for infinity over infinity form, based on the speed of approaching infinity in the numerator or in the denominator, both numerator and denominator approach 0 at almost the same speed, a very close speed, so the limit is a finite number. Or if the numerator is approaching infinity much faster, then this goes to infinity. Again, if we flip the fraction, this will approach 0. Now let's do a summary. Follow the speed of approaching 0 or infinity. The limit will result in 0 or non-zero finite number or positive, negative infinity. Let's have a look at these examples. First one belongs to finite over finite. Since negative 3 is in the domain, simply replace x by negative 3, we get the answer. Finite over finite will approach a fixed number. The next one is in 0 over finite form. Then the answer is a solid 0. 0 over non-zero finite number, the limit is 0. For this one, because 2 is not in the domain, the numerator is a finite number. Here is 0. We know finite over 0 can approach positive infinity, negative infinity, based on the approaching direction from right side or left side. So here, if x approaches 2 from the left side, very close to but still less than 2. So here is negative. The top always positive, right? Square plus 4. So the left limit is negative infinity. And the right side is positive. The limits of both sides are different, so the limit does not exist. This turns to be 0 over 0 when replace x by 1. We just learned 0 over 0 can have 3 possible results. So for this one, we by the FOIL factoring, the numerator has 2 factors, x minus 1 is gone. So we remove the quotient, 0 denominator. Then we plug 1 in x. You get a negative 1. Now let's move to limits at infinity. The first technique is to divide every one by the highest power of x in the denominator. Here we choose x to the fifth power as a divisor. So every one will be divided by x to the fifth power. And here is x to the power of 8 and x to the power of 5. Okay, here are all the steps. First, just divide by the highest power of x in the denominator. Then we simplify the fraction. And in the next step, based on what we just learned, like this is finite over infinity is 0. Finite over infinity 0, and finite over 0 is infinity. Infinity over non-zero finite is infinity. So we get infinity over finite is infinity. But here has negative, so this is negative infinity. Finite over infinity is 0. 0 over finite is 0. And here is just finite over finite. Another technique is we compare both degrees in numerator and denominator. If numerator's degree greater than denominators, then the limit goes to infinity. Here depends on f of x and g of x. The limit goes to positive and negative infinity of x approaching negative infinity. So same like here too. If m less than n, then the limit is a solid 0. If denominator and numerator have the same degree, then it's just a fixed number. Since we are talking about polynomial, so the keyword is leading term, also called dominant term. We only care about the leading term in numerator and denominator. Follow this technique. Here this degree is 8, here is 5, so m greater than n, and the limit goes to infinity. Because this coefficient is negative 2, here is 5. That's why this limit is negative infinity. And for this one, so m less than n is solid 0. Here both have the same degree, 5. So we extract coefficients, negative 2 over 5.